Welcome to Lesson 5C. In this lesson, we are going to be working with whole numbers, and we are going to be splitting them into parts, and then we are going to be transferring them or translating them into percentages. So why don't you take a moment to pause the video and go ahead and read the introduction to this lesson, and then come back and we will go through this together. Weighted averages are used when some numbers in a data set are more important than others for the final average. We often say these more important numbers are weighted more heavily than the others. When calculating a weighted average, the first task is to determine the weights for the numbers. These weights are often expressed as percentages. In particular contexts, there will be good reasons to choose certain weights for certain data points, but one rule that must always hold is the weights must always add up to 100%. And I would underline that for you. The one rule that must always hold is the weights must always add up to 100%. Keep that in mind. When we distribute the weights amongst the numbers, we have to distribute all of the weight, which is 100%. We're going to work through some examples now. So in this first example, you can read Carrie, Jacqueline, Nicole, Dorsey, and Ichiro, that's how I'm saying it, are all working on a group project together. So that is 1, 2, 3, 4, 5 group members. They estimate that if one person did the project alone, it would take 15 hours to complete. So when I'm going through all of this, I just always like to take note of what they told me. They gave me the names, and those are the group members. These are, I'll call them the members. And then I know it takes 15 hours to complete for one person. So those are just items I take into account. Now we have to read the question. It says, if the 5 group members split the work up evenly, so they want to split the work up evenly, how many hours of work will each person do? So whenever you're breaking something down, you are using the operation division. So when you're splitting up work and you want to break it down into equal parts, you are going to divide. So when you split work up, and then the big key word here is evenly. When it's evenly, divide amongst 5 people, because in this group, we had a total of 5 group members. So when it says, how many hours of work will each person do? Well, there are 15 total hours, and we want to divide amongst 5 people. And so that is going to be 3 hours per person. In part B, it says if 5 group members split up the work evenly, what percentage of the total work will each person do? Well, you can use this same concept. 15 hours is 100% of the work. You're going to divide that evenly amongst 5 people. So then you are actually going to get 20% per person. So 15 hours, let's keep this, is 100% of the work. You are going to divide it evenly amongst the 5 group members. That is going to equate to 3 hours of work per person, which is 20% of work per person. So this 3 hours is equivalent to 20% of the work. So this is as basic as it gets when we are splitting a whole into parts. When you break things into parts evenly, when you're breaking it down, the operation is division. And then you're just going to count up the number of people that you're going to break it evenly into, and you divide by that number. And then you can get the part that you are looking for. So this is the part that we were looking for. And this was the whole that we started with. And this was what we split. This was the splitting was going right here. And it was splitting equally among the group members. Okay. So now let's just take that, that's the basic, and then let's move on to another example. In this example, the group decides some of the students will do more work on the project than others. Carrie will do 50% of the work, Jacqueline will do 20% of the work, and Nicole and Dorsey will each do 10% of the work. All right, so they are giving this information to you, and they started to, when you're provided information, it's always a good practice to go ahead and try to organize it in a fashion where you can see what you have and what you know. And then it becomes a little more clear, the parts that are unknown and the parts that you need to solve for. So here in part A, it says each row will do the rest of the work not done by Carrie, Jacqueline, Nicole, or Dorsey. What percentage of work will each row do? Well, they went down here and they put a nice little table together. They labeled the group members, Carrie, Jacqueline, Nicole, Dorsey, and then you have Ichiro, who was the last one. And they assigned them each the percentages of work that they documented that they would do. You have 50, 20, 10, 10. And then we know that the total amount of work must add up, it's 100%. So what I'd like you to do is take a minute, think about how would you solve what percentage of work that each row would do. What would you do? So go ahead, pause the video, try to figure that out on your own, and then come back and join us. Okay, so I'm not sure how all of you would go ahead and solve this, but again, when we are looking at our total must add up to 100%, we already know what these percentages are. You have 50, 20, 10, 10. So 50, 60, 70, 80, 90. I know, kind of drew that for me, that is 90%. And my total must be 100%. So I'm going to do one of two things. 90 plus what equals 100, or I'm just going to go 100% minus 90, and what is left over? I have 10%. Okay, what must I add to 90 to get to 100? I'll put my percentage signs here, is 10. So in this answer, each row has 10% of the work to do. So if Carrie's doing 50, Jacqueline 20, Nicole 10, Dorsey 10, then each row there's 10% of work left over to make up 100%. So then in the next part B, it says the following table lists the percentages, the total work each person will do. Recall the total amount of work to be done on the project is 15 hours. And they went ahead and they put that in the table here. So the total was 100%. The total hours worked is 15. Fill in the third column with the hours of work that each person will do. You will also need to input each row's percentage from part A. So go ahead, I put in the percentage for each row for part A, and now we need to solve for this column. So it's not as clean as what we had done before, where we were dividing these into equal parts. I took the 15 hours and I divided it equally amongst the groups. Now we've got different percentages. So keep this in mind. You are going to take column B, so the second column, you are going to take the percent, you are going to multiply it by the total hours, which is the whole here, and then that is going to equal the part. So if I can go ahead and write that, I'm sorry, if I can scroll down here a little bit more for you, not here. You are going to take the percent in decimal format, you are going to multiply it by the total hours worked, which we know here is 15, and then that is going to equal the part, and that will be hours worked per person. Okay, and one thing to remember here, how do you change a percent to a decimal? To change a percent to a decimal, this is just a little reminder, you are going to take the percent and you divide by 100. Another way to divide by 100 is to move the decimal 2 places to the left, but you just can take each number here and you divide by 100. So what I'd like for you to do is go ahead and pause the video, try to complete this that last column on your own, and then come back and we will go ahead and do it together. Okay, so now that you've tried to go ahead and complete the hours of work done by person, let's go ahead and do some of these together. The first thing we need to do, we have to fill in Ichiro's percent, which we know was 10, which came over from the other answer, from part A. And now we're going to complete part B. And with part B, to get the number of hours done, again, the formula was, you have to take your percent and you're going to multiply it by the total of hours worked. And again, I'm saying that's the whole. The percent times the whole is going to equal the part, which is going to be the hours worked per person in this example. And the percent, remember, this needs to be in a decimal format. So now let's go to Carrie. So the percent of hours that Carrie worked was 50%. We want to multiply that by the whole, which is the total hours worked, which is 15 hours. And that is going to equal the number of hours that she worked. Now remember, we have to take this 50% and we have to turn this into a decimal format. So what you want to do here is you want to divide by 100 and you get 0.50 times 15, and that is going to equal 7.5. So the number of hours work done, 7.5. Let's go on and do Jacqueline. So Jacqueline, you have 20% times 15. That's going to equal some total number. And what you need to do, remember, change this percent to a decimal. How do you do that? You divide by 100. So you get 0.20 times 15. And you get 3. So you want to fill in 3 here. Then we've got Nicole. So you have, and Nicole, Dorsey, and Ichiro all have 10%. So what I calculate for one, so Nicole, we could actually say this is also Dorsey and it's also Ichiro because they're all 10%. You're going to do 10% times 15 equals some number. You take that 10%, you have to divide it by 100 to put it in decimal format. So you get 0.10 times 15, and that equals 1.5. So each one of them has 10%, so these are all 1.5. So I filled in my chart, I'm done, right? Well, I would never just fill in a chart and then just move on and walk away. I would always want to make sure that I look back at my results and ask myself, do these make sense? So what do you think you could do to, when you're looking at these numbers that you just calculated by hand, you calculated them all by hand, what could you do to look back and say, do these make sense? Well, remember, all of these hours they are all parts of the whole job. And the whole job is 15 hours. So in order to check, do these numbers make sense? I am going to take all of these calculations that I did, I'm going to add them up, 7.5 plus 3 plus, and you go 1.5 plus 1.5 plus 1.5. I probably would have done 3 times 1.5, but whatever you want to do, you want to sum all of these numbers that you have. And if this totals the total amount of work, then I feel good about it. So I have 7 So I'm going to start with 1.5 times 3, and I get that's 4.5 here, plus, and then the 3 plus the 7.5, I'm going to add those up. 4.5 plus 3 plus 7.5, that sums up to 15. 15, 15. Now I feel good about what I calculated. These numbers all seem to make sense. The 50% is more than the 20%, which is more than all these 10%. I feel good about it. We can go ahead and move on. But remember that one point that we always said, the percentages must add up to 100%. Therefore, all of the parts that you solve for must also add up to the total part, which here was 15 hours worth of work. Okay, so let's now move on. We're ready to move on for the last example here. In Shakespeare's tragedy, King Lear, the elderly king decides to divide the island of Great Britain evenly between his 3 daughters. He has 3 daughters, Regan, Goneril, and Cordelia. Let's imagine that instead of dividing the kingdom evenly, King Lear divides Great Britain as follows. Half goes to Regan. So let me underline this. Half goes to Regan. 1/3 goes to Goneril. And then the rest, the rest goes to Cordelia. Okay, so we've got our 3 pieces. So Regan, she's getting half. Goneril's getting 1/3. And she gets the leftover. What's ever left over. Okay. Great Britain has an area of 209,000 square kilometers. So he is splitting up his kingdom. He's splitting it up how he described. And this is the total amount of the kingdom that he is splitting up. Complete the following table using this information. Round to the nearest 1/10 of a percent in the second column. So we want to go to the nearest 1/10 here. I'm just taking notes here because we tend to forget that as we work through the problems. So we want the nearest 1/10 in this column and the nearest 1,000 in this column. So nearest 1,000. So this will be a whole number here. Okay. So the sum of the areas is not 209 due to rounding. Okay, so when you start rounding, so we're rounding this to the nearest 1/10, when we have these numbers and we do our checks, they may not add up exactly, but we can do our best and make it close. All right, so here we go. So when we have Regan, he lists so this is the organizing of the information that you've been provided, and tables work fabulously here. So you have the daughters, and there are 3 of them. The percent of the kingdom, you know the total percent of the kingdom is 100%, and he gave descriptions as to how he was going to split it up. And you know the total area of the land that they are splitting up is 209,000 square kilometers. So let's fill in what we know. We do know Regan is going to get half. So what is half of 100%? There are many ways to think about it. Well, half of 100%, if I just take 100% and divide it by 2, because that 2 parts, that would be half, that's going to give you 50%. So half is 50%. Now Goneril is going to get 1/3. So and now we got to do a little calculation here, 1/3. So we want 1 Regan. So Regan has half, and we know that's 50%. That one's pretty simple. But then you have Goneril. She's going to get 1/3. I'm going to write that of 100%. So what you want to do is take this and multiply 1/3 by 100%. Now remember a fraction. When you write something in a fraction form, you have 1, you've got the fraction bar and 3. All that means is 1 divided by 3 of, that means you're multiplying 100%. So go ahead and type that in your calculator. 1 divided by 3, it's going to is 0.33333333, and times that by 100, you are going to get 33.3333, and it's going to go on repeating forever. It said round to the nearest 10th here. So that's another little definition and a skill, hopefully remember from previous lessons. But the 10th position is this first digit to the right of the decimal point. So that is our 10th digit. Then in order to know what to do with this digit, to round it, you must look to the right, to the next digit. It's a 3. So when I'm looking at the 3, that is going to determine what I do to this 3. So here's the rule. If it's 4 or less, you leave this underlined digit alone. If this digit to the right is 5 or more, you increase the underlined digit by 1. Well, we have the digit 3, so it's 4 or less. That means we leave this underlined digit alone. So our percentage for gonorrhea is 33.3%. And then the rest goes to Cordelia. So now how do we determine the rest? All right, so again, we're looking for this missing part in the middle here. So you're looking for that missing part. We know we've got 50 plus 33.3. That sums up to 83.3. 83.3 plus what equals 100? All right, so all we're going to do is take 100 minus 83.3, and we get 16.7. So I'm going to erase that in there. I'll put in 16.7%. So it's a little messy in here. I'm sorry. You have 50%, 1/3 is 33.3%, and the rest goes to Cordelia, which is 16.7%. So 16.7. How did we get that? All I did was take 100 minus 83.3, and that's how I got my 16.7%. Okay. So now let's clean this chart up, because now it wants us to figure out how much of the area do each one of these daughters get. So let's go over here. We know this is 50. We've got 33.3 and 16.7. I'm just bringing these over from the previous page. And now we need to calculate the area of the portion that each kingdom gets. And remember how we do that. You take the percent in decimal format as a decimal. You are going to multiply that by the whole amount, which here is going to be the whole area of the kingdom, which whole amount, which here in this example is the area of the kingdom, which is 209. Okay. And then that's going to equal the part amount, which is the portion of the kingdom each daughter gets. Receives. All right, so I want to make sure you understand not just the numbers, but kind of what we are getting out of it. So you're taking the percent. Remember, you must put it in decimal format. How do you do that? You divide by 100. You multiply that by the whole amount. In this example, it's the area of the kingdom, and the total area of the kingdom is 209,000 square kilometers. And that is going to equal the part amount that each one of the daughters receives. And that's going to be, each daughter is going to receive a portion of the kingdom, right? So let's go through each one of these. You have Reagan. She has 50% times the 209,000, and that is going to equal some portion. So you have 0.5 times 209, and that is going to equal 104.5. All right, and I think it said to round these to the nearest 1,000. So this one, if we rounded that, it would be 105. Why don't you pause the video here and go ahead and calculate the portions of the kingdom that's going to be calculated for gonorrhea and Cordelia, and then come back and we will go ahead and finish that together. Okay, so let's see if your answers are correct. So then we have, let's go through gonorrhea. We are going to take 33.3%. You want to multiply that by the whole, which is 209. So that's 0.333 times 209. That's going to equal 69.597. If I round that to the nearest whole thousand, that's going to be 70. And then I'm going to have Cordelia percent times 209. So that's really 0.167. So again, that would be 35. So if you plug in 104.5 and 69.597 and 34.90, that would be a 3 here. You add those up, that should give us that 209. But in here, we are rounding it to every one of these to the nearest thousand. And again, we would have to, these are the digits that we're working with. Each one of these ended up rounding up. So we have our 105, we have our 70, and we have our 35. Again, you're going to ask yourself, do these make sense? In order to see, do these make sense, you want to sum those up. And when you sum them up, you get 210. And I'm going to say that is okay. And that is okay because we rounded. And when you round, it may not add up exactly to this, but as long as it's close, this is 210, that's 209, these numbers still make sense. All right. So whenever they ask you to round, understand you're not getting exact answers. When you don't get exact answers, you're not going to exactly add up to the total, but as long as it's close, it's reasonable. And I think 210 is reasonable. And when I look at all my rounding, I noticed that every one of them none of them stayed the same. This didn't stay to 104, it went to 105. This didn't stay at 69, it went to 70. And this didn't stay at 34, it went to 35. So my guess is this would be a little higher. Okay, so again, that all makes sense. So hopefully that is clear on how you take a percent, you know a whole, and you can split it into parts and translate those into percentages and total amounts. Now, mind you, we did all of these manually by hand. A good tool that you could use. So see how we organize this into a nice, neat table, and then we have all this messy work, and then we put our messy work all into this nice, neat table to keep everything organized and clean. That's a good practice to get into. So this is kind of our scratch work, and then we organize it and present it in a nice, neat fashion. Well, there is a tool that you can use that can do this, a lot of this messy scratch work for you. It's called Excel. So here is what they did in this next problem. The following is a screenshot of the data from question 2 entered into a spreadsheet in Microsoft Excel. So you open your own blank Excel sheet and type in the same information. Note that column 3 or column B is formatted as a percentage. This means that while the values in the column are displayed as percentages, they are stored as their decimal equivalents. So remember, I had to take every percent and convert it to a decimal. Excel, it already knows to do that. It's already programmed into the application. And there, so for example, B3 displayed as 20%, the value is actually 0.2. Okay, so why don't you take the time, pause the video, go ahead, open up Excel, and then type all of this information in, and then we're going to go back and we're going to refer to the Excel spreadsheet to complete the rest of the lesson. All right, thank you for coming back. I am going to go ahead and pull over an Excel spreadsheet that I've put together. I want to open up. Here is the workbook pages that we are going to be working from. So part A, it wants us to go through that the percentages must add up to 100%, and we're going to figure out each row's percentage. The next one, part B, it's going to actually, then it's going to ask us which cell contains the value of the total hours work done. So it wants you now to hunt onto the spreadsheet just to gauge where all the data is. And then it tells you about absolute cell referencing. So when I go through this, I will put formulas into Excel, and then I will actually do what they tell us to do with this absolute cell reference. And then I'll show you when you don't do the cell reference, what will happen. And then it tells you what formula will you enter in cell C2 to compute the hours of work done. Okay, so these are what we're going to be working through. You will be able, at the end of this lesson, I'm just going to go through the Excel spreadsheet, but you should be able to fill in these answers from my work on the Excel spreadsheet. So you may want to have them side by side. Okay, so all we did was take the question that we had from lesson 2, and we went ahead and I typed it all in. So you just type in group member, carry. I put in 50%. Now we know the total percent here must add up to 100. I can key in 100% because, oops, that's what it's supposed to be. But instead of me keying 100%, I'm going to type in a formula. And again, how do I know what the formula should be? Well, all of these percentages should sum up to 100%. So I'm going to go equals sum, and then they will tell you to type B2, and that gets me B2. And then you want to go down, colon, and then you want to include every one of these. So each row would be B6. So now it highlighted those rows that I'm going to sum up, put my parentheses to close that out, and I type enter, and you can see that it's only 90%. So again, I can do 100% minus 90, recalculated 10. There's a whole bunch of ways, but I know I want this number to be 90. I can just randomly type a number, 5. Oh, it's doing 590. Why did it do 590? Because it wasn't a percent. So if I type in 5%, oh, I'm at 95%. I'm not high enough. So then I can just type in my 10%. Yep, I got to my 100. So in my head, again, if I remove this out, I'm only at 90. I know I need to get to 100. How much more do I need to get to 100? 10%. If you type in 10%, there is my 100. Okay, and that's because I did my sum in this bottom. All right, so now right here, I just have the number 15, and this is the total number of work hours done. So we're going to show you how we're going to do these calculations, and then we'll show you how to, turn this into a sum to make sure our numbers make sense. So now remember the hours of work done. You take the percent and you multiply it by the total, and that's going to give you the part. So again, you want equals 50%. So you see how I referred B2 times, oops, times is the star over the number 8 times, and then it's 15. And you get 7.5. Now I could go ahead and copy that down, and notice when you in Excel, see how quickly that went? Whenever you do a cell reference and I go to the next row, this is B2. So then when I go down to the next one, this should say B3. See how it did that? And then the next one would say B4. And the next one will say B5. And then this one will say B6. And that worked out very nicely because then I just typed the number 15. Just like we typed the number 15 for the total, I typed the number 15 here. That's one way to do it. Now, normally when you're pretty proficient in Excel, you wouldn't do it this way. I probably wouldn't do it this way. I would type equals my 50% times, and I'm going to refer to cell C7. Okay. And then this is where what will happen if I don't. Let me just put it over here because I'm not going to do. So 50% times, and I'm going to refer to my cell reference, C7. because it's always better when you refer to cells, because then you can just copy and paste. You don't have to worry about what was that exact number. Now, they gave us this thing about cell referencing. So I can go back to that and let's read this. Sometimes we want Excel to use the same value from the same cell in a series of calculations. To do this, we use absolute cell reference. This is accomplished by placing dollar signs around the label for the column. For example, in the table above, the absolute cell reference for the total number of hours is $C, $7. So the total number of hours was 15. You'll notice that I keyed 15 in that first column. Just remember, and we'll go back to that. But then this time, I just referred to it as C7. So let's go back to Excel. So when I did the cell reference, you'll see that this is in column C, row 7. So that's called C7. Well, if I go ahead and paste that down, remember what I told you over here. When I copy that formula down, B2, in the next row, it's going to turn to B3. And the next row, it's going to turn to B4. Well, that same thing will happen with C7. So it will go, so when I go down to the row, B2 will become B3 and C7 will become C8. Well, in C8, what do I have? This is cell C8. There's nothing. I didn't want it to go to C8. I didn't want it to go. And so you'll notice how it did that. It went B4, C9, B5, C10, B6, C11. I didn't want that to happen. This is why I did not use the absolute cell reference. So what they're saying is to do an absolute cell reference, to always go back to this cell, you must do $C, $7. So I will do that right here. So I have equals the 50% times $C, $7. So now, and notice how when I did that, well, let's do that again. $C, $7. Notice how it grabbed cell. You can see the two highlighted cells. So as soon as I type that, you've got this 50% highlighted and you got your 15 highlighted. That's exactly the calculation you want. Hit enter. You get your 7.5. Now here, when I copy and paste, notice that my values are correct, because once you do this $, this absolute cell reference, it's going to hold that number. So when this one is still going to go to B3 because I didn't do any absolute cell reference, it's going to say, oh, I'm at B2. When I go down a row, I'm going to be at B3. However, I'm going to hold my C7 because I did an absolute cell reference. This one says, okay, I'm going to go now on the next row, I'm going to go to B4, and then I'm going to hold the C7, and so on and so forth. And then to check your work, again, the sum better add up to 15. And it does. Where here, your sum, when I did not do the absolute cell reference, it only added up to 7.5. And that was because when I referred to cell C7, I didn't make it an absolute cell reference by putting the $sign before the C and the $sign before the 7. So in Excel, it remembers if I don't see any absolute reference, I'm just going to increase. When I go to the next row, then each one of these values is also going to go to the next row. And that's not what we wanted in this formula. Okay, so hopefully that was a little education on Excel for you. This is a great tool to use, especially when you're organizing your work and you have that messy scrap work. Excel can do all of that scrap work for you. So I suggest that if you just watch the video and observe this, that you go ahead and do this, practice this on your own, and ask questions in your next class. All right, thank you.